All right, still working on problem 9. This is problem 81. Sorry, homework 9. This is problem 81, page 147. And you are assigned, I think, problem 82 here. And these two are very similar problems. And again, we're working with quadratics. We're finding the vertex. We're finding the intercepts. In this case, we're going to find a number of properties, and we're going to graph the function. So as before, you can approach this a number of different ways. I'm going to start over here using this vertex form approach. And in order to do that, I've got to recast f of x into the vertex form. And that takes completing the square. So I'm going to take the first two terms. I'm going to divide the second term by 2. And get 2, I'm going to square that and get 4, and then I'm going to add a 4, and I'm going to subtract a 4 and carry along this minus 25. And as the next step, I'm going to see that these three terms are a perfect square. They are x plus 2 squared, and then I'm going to combine the minus 4 and the minus 21 to get minus 25, and there we have it, the vertex form. And with this form, one can immediately write down that the vertex is minus 2 minus 25. And we can kind of satisfy the requirements of this problem by writing the answer there. And what the vertex form does not do for you very nicely is to find the x-intercepts. And so maybe what I'll do is start the problem again, rather than using this vertex approach. Let's just go and find the zeros directly, and to do that, we can really take two approaches there. So in this case, we're going to call this blue convert to vertex form. And I'm going to call this purple color finding the zeros. And of course, I can do that a couple of ways. I can see pretty quickly, though, that in this case, we can factor this. I've got a 21 over here. A 3 and a 7 will do the trick there. And if, in fact, the term associated with the 7 is a plus and the term associated with the 3 is a minus, then when we multiply this together, we're going to get 7x minus 3x or plus 4x, just exactly what we want. And with the f now cast in this form rather than vertex form, you can see the zeros instantaneously. They are 3 and minus 7. So there are the x-intercepts. The x-intercepts are 3, 0, and minus 7, 0. And maybe I'll leave it at that. I just can't leave it at that. Let's just use the quadratic formula as a way that always produces the two zeros for you, whether they're real or imaginary. Brute force, they just come out, and in that case, you just have to remember that x, if x is one of the zeros, is the opposite of b, plus or minus the square root of b squared minus 4 times a times c. C is a minus 21, so I'm going to put the 21 there, and I'm going to change that sign. So it's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, which is 2. And now if we just look hard at this, this is 84 plus 16 is 100. The square root of 100 is 10. So this is minus 4 plus and minus 10 all over 2. So we're going to get minus 4 plus 10 is 6 divided by 2 is 3, or we're going to get minus 4 minus 10 is minus 14 divided by 2 is minus 7. So sure enough, try as hard as we might, one way or the other, the zeros are 3 and minus 7. So part C of this problem says do the following. let's let y be equal to minus 21. I'm not quite sure why I drew the graph in that manner. Let me try again. Let's let y be equal to minus 21. Okay. Let's find the value or values of x which at which the graph crosses y equals minus 21. And to do that, all we have to do is to say that f of x is equal to x squared plus 4x minus 21, and set it equal to 21, minus 21. And when we do that, we're going to find that x squared plus 4x is equal to 0. We're going to factor out and get x times x plus 4 is equal to 0. And that says that x is either equal to 0 or x is equal to minus 4. All right, so this thing is defeating me a little bit. Here's x equals minus 4. Here's x equals 0. If I put x equals 0 into this equation, sure enough, you can see that I get minus 21. And if I put x equals minus 4 into this equation, 16 minus, I get 21. And so if I was to go further with this and draw a graph, I've got a couple of different bits of information. I know exactly where the vertex is, right? So let's color code this stuff. I know where the vertex is. The vertex is at minus 2, minus 25, right? I know where the zeros are. The zeros are at 3, 0, 1, 2, 3, 3, 0, and minus 7, 0. Minus 7, 0. And I know what 2 points cross over, does the graph cross over when y is equal to minus 21. It's these two as are written. So pretty simple at this point to draw the quadratic that results. Thank goodness I didn't have more color pens. So that's problem 81, page 147.